So today we are going to study about relations. So before going to relation, let us understand what is a Cartesian product. Okay. So let A and B are two sets. Let A and B are two sets. The Cartesian product of A and B. The Cartesian product of A and B written as A cross B. The Cartesian product of A and B written as A cross B, which is a set defined as follows. So let A and B are any two sets. The Cartesian product of set A and B is written as A Cartesian product B, okay, which is a set. So A Cartesian product B is itself a set which can be defined as set of all A order pair A comma B, such that small a belongs to A and small b belongs to B. This is called the Cartesian product. Cartesian product of A and B, it's a set which can be written in set builder method like this. Set up order pairs A comma B such that A belongs to A, small a belongs to A and small b belongs to B. Example, let A is equal to and B is equal to, then A Cartesian product B. So make a order pair. Always remember, start from order pair from A to B, not B to A. Understand? So you write A comma 1, then A comma 2, then B comma 1, B. This is the Cartesian product A cross B. Very simple. And find out B cross A. So now start the order pair starting from element B to A. So this will be 1 comma A, then 1 comma B, 2 comma A, okay. So what is the conclusion? Conclusion is A cross B is not equal to B cross A. Both are different. See here, this set and this set, both are different set because elements are different. So A cross B not equal to B cross A. Okay. Second, what is the cardinality of A cross B? Cardinality of A cross B. 4. So let's suppose here I down Mn, M into N, where cardinality of A is equal to M and cardinality of B is equal to M. So number of elements in A, number of elements in B. Multiply this, you will get the cardinality of A cross B or B cross A, both the same. Okay. So any doubt here? Okay. So let us solve one problem. question. Find the power set. Last class I told you about this. Find the power set of A cross B, where A is equal to A and B is equal to 1, 2. Find the power set of A Cartesian product B, where set A is equal to only one element is there, and in B there are two elements, 1 and 2. Find the power set of A cross B. First of all, let us find A cross B. A cross B is how much? A1, A2. This is A cross B. Now we will find the power set P of A cross B. We know that phi is the subset of every set. You have to find the subset of A cross B. One more subset. Which one? So you have to write like this. Then another A2. And the last one is A cross B. Either you write the entire set, this one, or instead of this write down A cross B. Okay, so this is the power set. So here also, if in the question is given, find the cardinality of A cross B. Cardinality of A cross B कितने होगा? Cardinality of A is 1. Cardinality of B is how much? 2. Cardinality of A cross B is equal to 1 into 2 is equal to 2. Cardinality of power set, this one, is equal to कितने? 2 to the power 2, that is equal to 4. This is the 4. 1, 2, 3, 4. Okay. Okay, now come to relation. Okay, so in this book there is instead of relation it is written as binary relation, because it is relation between two elements. That's why it's called binary, because we say two as binary. So definition is a binary relation. A binary relation from A to B. Relation is always from one set to another set, where A and B are the two sets. A binary relation from A to B is a subset of A cross B. Very simple. Binary relation from A to B is a subset of A cross B. How many subsets are there of A cross B? How many subsets are there across B? Okay, so let this is M. Cardinality of A is M. Cardinality of B is N. Then cardinality of A cross B is how much? Mn. Okay. So total number of subsets of A cross B कितना होगा? Is equal to 2 to the power mn. I told you in the previous slide. This is A, cardinality of A, cardinality of B. Cardinality of A cross B is how much? 2. So cardinality of power set means number of subsets of A cross B or A cardinality B. That is the cardinality of power set. So these are the subsets. This. Okay. So we tell each and every set as a relation. So here phi is relation. Okay, from A to B, as well as A comma 1, order pair A comma 1 in the set. So this is a relation. This is also relation, and this is also relation. Okay. So if the cardinality of set A is M and cardinality of B is N, then cardinality of A cross B is how much? Mn. Okay. Total number of subsets of A cross B is 2 to the power Mn. So what is the total number of relations from A to B? Kete hobo? Total number of relations from A to B is equal to how much? Huh? Answer is there in the slide itself. See the definition. A binary relation from A to B is a subset of A cross B. How many subsets are there? A cross B. 2 to the power mn subsets are there. So there are 2 to the power mn number of relations are there from A to B. As well as phi is also a relation. That is an empty set. Okay. So this कितने होगा? 2 to the power mn. Okay. Example. Find all the relations from A to B where A is equal to xy comma B is equal to A. Find all the relations from A to B. How many relations will be there? Total relations? How many? Hmm? 4. There will be 4 relations because here the cardinality of A is how much? 2, 1. Cardinality of A cross B, that is equal to 2 into 1, that is equal to 2. So the cardinality of power set, 2 to the power 2, that is equal to 4. So that is actually 4 number of relations are there from A to B. Find those relations. Find karo. So A is xy. A is how much? This is xy. B is A. Okay. Find out A cross B. XA. Then sorry. YA. Hello. Anything possible? 2 elements will be there. Now relations from A to B. Hello. So तुम्हें कौन करियो? First of all, find the power set of A cross B. Power set of A cross B कितने होगा? Phi first one. Second, what element नियो? Take one element. This one. Third, YA. This one. Okay, so don't forget this. This is the outer curly verses written in red color. Ella, power set. It's a set, na? Set of subsets of A cross B. Ella. So, what are the relations? Relations are ek number. This is the relation. One relation, phi. Ella. Or you may write empty set like this. Second relation, this one. Third relation. And the last relation, fourth relation, XA, YA. This one. What is the definition says? A binary relation from A to B is a subset of A cross B. Dekho. Phi is the subset of A cross B or not? This one. এইটি जोटा अछि सबटा सबसेट अटंती पावर सेट जेते एलिमेंट समस्त सबसेट ऑफ A क्रॉस B phi is the subset of A cross B even this is the subset because this XA order pair XA element is there here XA so everything is subset so these are the relations how many relations are there four relations are there okay so there are how many relations four relations hello any doubt okay now come to next types of relations okay so before going to types of relation let's have one more definition binary relation on set A. Okay, a binary relation on set A. In the previous definition, what I told you, a relation from A to B, I told you. A to B, there should be two sets from A to B. But here, what's written? Binary relation on set A. So, what's the meaning of this? Binary relation from A to A, say A to A. Here, the both set are same. What I told you, A to B. Here, A is A and B is A. So A to A, that is called as the binary relation on set A. Okay. So in the diagram, what actually I told, this is the A set, this is the B set, this is the relation, represented as R. So it will be said as binary relation from A to B. Understood? But if it is A, this is also A. Let's suppose this one is R1, this is R2. Then R2 is a binary relation from A to A. In the short form, it is written as binary relation on set A. बुझे ला A to A न कही जे short form में कौन कहा जाए binary relation on set A. Okay. So actually now onwards we will study this one binary relation on set A. We will define a set A, then we will find the relation on set A. So definition is a binary relation from a set A to A is called as binary relation on set A. Come to one example. Let cardinality of A is equal to n. Total number of binary relation on set A is equal to कितना होगा total number of binary relation on set A कितना होगा 2 to the power n is correct what is the cardinality of A n what is the cardinality of A cross A because the binary relation on set A is nothing but the subset of A cross A because instead of B I have written A cross B previously I was writing but here I will write A cross A what is the cardinality of A cross A n into n square 2 to the n square okay so total number of binary relation is कितने 2 to the power potential तो about what I was writing 2 to the power mn लिखूँ थी ना mn But here m and n both are same. So write down 2 to the power n into n, that is n square. Total number of binary relation on set A is equal to 2 to the power n square. Okay, na? So any doubt? Binary relation from A to B, two sets are different. Now if I say binary relation from A to A, that is called as a binary relation on set A. It is written here. Binary relation from set A to A is called as binary relation on set A. Types of relation. First one, reflexive. Let R be a binary relation on A. R is said to be reflexive. R is said to be reflexive relation if A comma A is in R. If A comma A is in R for every A in capital A. Okay, so see here, for your simplicity, RB is said to be A. I will write A like this. Because this A is the element here. Understood? This A is nothing but the element. I will write down another color. Okay, so here A comma A. This A এটা কোন অটে? This is the article অটে, the and A. আমি the A and use করছি না। কিন্তু এটা অনকা লিখে। So there will be no confusion. No on a color level লিখে দিই। So R be a binary relation on A, then a full stop there. R is said to be reflexive relation if order pair A comma A is in R for every A in A. For example, let's suppose capital A is A comma B. Okay, let's suppose R1. Okay, now tell me, is R1 is a reflexive relation? Is R1 is reflexive relation? Yes, because in A, how many elements are there? Two elements are there, A comma B. If A belongs to small a belongs to capital A, then there must be order pair A comma A belongs to relation R1. देखो ये order pair A comma A भी होची, B comma B भी होची. For every element, it's written for every A in capital A. Hello, any doubt? Okay, if I say R2, is this a reflexive relation? It's a reflexive. Is this a reflexive relation? R2? Yes or no? Yes, because this is the mandatory. This must be there, and rest may be. So this is the rest element that may be allowed. R3. Is this the binary? Is this the reflexive relation? Yes or no? No, because B comma B is not there. Order pair B comma B. Every elements A comma B is there in capital A. So there must be order pair A comma A as well as order pair B comma B in relation. And that relation is said to be reflexive. Now last relation R4, 5, empty set. It is also relation, I told you. So is it a reflexive relation? Yes or no? No. because this phi is nothing but empty set. So here a comma order pair a comma a and order pair b comma b are not there. This is not a reflexive relation. Okay. Another example. Let a be a set of natural numbers. So see here how I am defining a relation. First of all, you have to define the set A. Okay, then we will define this relation R. Let A be a set of natural numbers let R be a relation on set A. Let R be a relation on set A such that if X belongs to capital A, sorry, uh, let R be a relation on set A such that X comma Y belongs to R if and only if X divides Y. R is a set. तांको elements को केमती अछंती order pair अछंती अछंती कि नहीं? So I can say X Y belongs to R. Let A be a set of natural numbers. Let R be a relation on set A such that if X comma Y belongs to R, if X divides Y. है ना? और ये लिख दियो. And X comma Y belongs to A. Both elements are in A. Now tell me whether this R is a reflexive relation or not. Yes. First of all, define this R. So R is a relation on set A. And what is A? Set of natural numbers. Okay. So I can say 1 comma 2. होगा कि नहीं? Because 1 divides 2. 1 comma 3. होगा. As well as 1 comma 1 भी होगा. होगा कि नहीं? Then 2 comma 2 होगा. 2 comma 4. And so on. Okay. I have just written it in a tabular method. Just try to see here. Now we have to analyze whether R is a reflexive relation or not. We know that every natural number divides itself. We know that every natural number divides itself. Means 1 1 must be here in R, 2 2 must be there, 3 3, 4 4, 5 5, and so on. Therefore, R is reflexive. Okay, any doubt here? But let's suppose instead of this natural number, if I write down integers, let A be a set of integers, R be a relation on A such that if X comma Y belongs to R, if and only if X divides Y and X comma Y belongs to A. है ना? यदि मु set of natural number को change कर देली, set of integers कर देली एक, then will that be a reflexive relation? Reflexive relation होगा कि if I change the set A from natural number to set of integers. Why? Yeah, because 0 is in natural, sorry, in set of integers. 0 do not divide 0 itself. So there is one exception. So 0 comma 0 cannot be in set R. Okay, so there is one exception. That is why that will not be a reflexive relation. If I replace this natural number with set of integers. Okay. next hela symmetric relation. Okay, okay, yeah. Definition of symmetric relation is equal to. Mhm. Okay, so whenever you define, let's suppose in your exam, define the symmetric relation. So how do you define this one? First of all, first of all you have to write it like this. Let R be a relation on set A. So you have to write down this line first. Let R be a relation on set A. Okay. Then come to the definition. Said to be R is said to be symmetric relation if A comma B I am writing in theoretically. If A comma B in R implies that B comma A is also in R. Mathematically, what will I write? If A comma B belongs to R, it implies B comma A belongs to R. Then we can say that R is a symmetric relation. Example. Let I am giving example. Let A be a set of let A be a set of students. Let A be a set of students and let R be a binary relation on A such that A comma B is in R if and only if A is okay. So let me change this notation. Let me write down XY so there will be no confusion. If and only if X is in a class that Y is in. Okay. Now you have to check whether this is a symmetric relation or not. First of all, come to the example here. What it says, let A be a set of students. So A is a set of students. Okay. Let R be a binary relation on A such that XY is in R if and only if X is in a class that Y is in. Okay. Let's suppose this is your class. Okay, so let's suppose this is a university. Total lot of students are there. So A is the set of students of university. Let's suppose this is your class. CS, computer science. Okay. So what it says that XY, order of XY belongs to R if and only if X is in class where Y is in. Means X and Y are belong to the same class or studying in the same class. Okay. So what I say, XY is studying in the same class, then XY belongs to R. I can say in reverse way, YX studying in the same class. Come on, Ram and Hari studying in MSc Computer Science, which I can say Hari and Ram studying in MSc Computer Science. So this is a what kind of relation? Symmetric relation. So this is a relation. Definition of relation is given. This one. XY is in R if and only if X is in R, X is in a class that Y is in. Come to this example. Is this a symmetric relation? Let A be a set of natural numbers. Let R be a relation on set A such that xy belongs to R if and only if x divides y. Is this a symmetric relation? Hmm? Healthy. Just a simple. 3 divides 9. Is 9 divides 3? No. See the relation. Divides it's written. What is written here? X divides y. So take an example. X means 3 divides y. It doesn't mean that that y divides x because 3 divides 9. 9 doesn't divide 3. Understood? So this is not a symmetric relation. What is the time? It will. So this much for today. Let me give another example. Last example. Example number 2. Let's suppose B is a set having elements A comma B. R is a relation on B. Okay. So I can write R as R is a symmetric relation? Is R is a symmetric relation? First one is a symmetric relation. Example number 1. Yes, because A comma A, order pair A comma A. If you find the reverse, alter reverse, same you get A comma A. That is there in the relation itself. A comma B, B comma A is there. Okay, and for B comma A comma B is there, and for B comma B itself. So it is a symmetric relation. Fine. In the next class, we will study some other types of relation like antisymmetric and transitive.